Picture this. It is like 8:15 in the morning.
Oh boy, the absolute worst time.
Right. You are standing behind the counter of a brand new, highly anticipated tech cafe. It's right in the middle of a bustling downtown district.
And the doors just opened.
Exactly. The doors opened and the morning rush has officially hit. The ticket printer is just screaming at you.
I can hear it now. It's the sound of pure anxiety.
It really is. You are staring down a brutal, unrelenting 200 ticket hour. I mean, 200 coffees, all customized, all expected to be absolutely perfect, and the line is already snake backing out the door.
Yeah, that 8:15 rush is, it's the ultimate pressure test for any operation.
Totally. Now, normally when we do a deep dive, you and I are looking at, research papers or historical events.
Right, usually something a bit more academic.
Yeah, but today we are stepping into the shoes of high-volume hospitality consultants. We are acting as cafe operations experts.
I love it. We get to be in the trenches today.
We do, and we have a very specific mission. How do you actually survive that 200 ticket rush? How do you optimize for speed, for consistency, and most importantly, guest satisfaction when the pressure is just at its absolute highest?
Because in that environment, every single second counts. I mean, every wasted movement just compounds.
Right.
If a barista loses like 10 seconds fumbling with a machine on one drink, and you have 200 drinks in the queue, you've just added over half an hour of waiting time to the back of that line.
Oh, wow. When you do the math like that, it's terrifying.
It is. People will check their watches, they'll step out of line, and, well, they simply won't come back.
And to solve this massive operational puzzle, we are looking at a surprisingly technical source today.
Yeah, this isn't your typical customer service handbook.
No, not at all. We're not analyzing a book on managerial soft skills. We're looking at the literal engineer's manual for the Faema President GT espresso machine.
The actual physical blueprint of the equipment sitting on our hypothetical cafe counter.
Exactly. And it is a really unique document to pull hospitality insights from.
It is, mostly because, an engineer's manual doesn't mention smiles or eye contact.
Right. There's no chapter on greeting regulars by name.
Exactly. It outlines schematics, boiler pressures, electrical relays, stuff like that. But our job today is to translate those cold, hard technical specifications into a warm, seamless human experience.
Okay, let's unpack this. We aren't going to just read down a list of specs.
No, that would be incredibly boring.
It really would. Instead, we are going to follow the physical journey of making a coffee during that chaotic morning rush.
I like that approach. It mirrors what the barista is actually experiencing.
Right. So we'll start with how the barista interacts with the machine's interface. Then we'll look under the hood at the physical engine, the boilers.
Heavy metal.
Yeah. From there, we'll hit the biggest roadblock in any cafe, which is steaming the milk and how to bypass it. And finally, what to do when the rush starts to slow down, but your machine is filthy and you still have customers waiting.
Because before you even grind a single coffee bean, before water ever touches the cup, a barista has to actually interact with the machine's interface.
That physical layout totally dictates the rhythm of the workflow.
It really does. And looking at the schematics in the President GTI manual, instead of rows of confusing analog dials, they feature this prominent TSB selection touchscreen right at eye level.
Yeah, the diagram shows these large, unmistakable touch targets for the most critical adjustments.
Exactly. The manual points directly to specific shortcut menus. You have the unit keys, which is number 14 on the diagram.
Okay, all right.
You have the hot water keys at 17, and the boiler temperature right there at 16. All of those are sitting on the surface layer of the digital display.
So no deep menu diving.
Exactly. And that deliberate placement is an engineering choice designed specifically for speed.
Because in a rush, a clunky interface costs you those precious seconds we were talking about.
Yes. Think about an older traditional machine. If a barista needs to tweak the temperature, they might have to hold down 2 physical buttons for 5 seconds just to enter a programming mode.
Oh, I've seen them do that. It looks so stressful.
It is. They have to scroll through this tiny LCD menu, all while a customer is standing 2 feet away, just staring at them.
Which totally pulls the barista out of the moment. It causes so much friction.
It does. By putting these controls on a responsive touchscreen, kind of like a smartphone, the engineers have removed that friction.
So the barista can just tap the screen, make the adjustment instantly, and keep their head up.
Exactly. When a barista is buried in a complex analog machine, their eyes are glued to the metal. But with an immediate digital interface, they can maintain eye contact, chat with guests, and deliver actual hospitality.
While the machine does the heavy lifting in the background.
Right.
Okay, I hear what you're saying about speed and eye contact, but I have to play devil's advocate for a second.
Go for it.
I feel a slight twinge of regret looking at a touchscreen on an espresso machine. Doesn't that take away the romantic, tactile feel of traditional espresso making?
I know exactly what you mean.
You know, the clanking of levers, the heavy twisting of mechanical dials. It feels like we are moving from a classic stick-shift sports car where you feel every gear click into place to a modern car with those little electronic paddle shifters.
Right. It's undeniably less romantic.
Yeah,
That is the perfect analogy, honestly.
Yeah.
You do lose a fraction of that old world romance. But think about why high-performance race cars use paddle shifters instead of heavy stick shifts.
Well, because paddle shifters change gears in a fraction of a millisecond.
Exactly. In a high-volume tech cafe, speed is the highest form of hospitality.
Oh, wow. Speed is hospitality.
Yeah. The customer who is running late for their 9 a.m. tech stand-up, they do not care about the vintage romance of a mechanical liver.
No, they really don't.
They care that their drink is flawless and handed to them in under 3 minutes.
Ah, okay. When you frame it like that, clinging to the heavy manual dials is actually a bit selfish on the part of the barista.
It kind of is, yeah. You're prioritizing your own romantic experience over the customer's time.
So the touchscreen absorbs that operational friction so the barista can prioritize the guest. I love that.
Me too. So the interface is fast, the barista taps the screen, the order is locked in. Now we need the machine to actually brew the coffee.
Right, moving from the digital screen into the heady metal of the machine.
And a fast interface is completely useless if the physical engine boiling the water can't keep up with a barista pulling shot after shot.
Which brings us to the GTI's thermal advantage.
Yes, this is where the manual gets incredibly granular. The President GT isn't just a large metal box holding one massive tank of hot water.
Okay.
It's built on a system of independent boilers. If you look at the internal schematics, there's the main service boiler, which the manual calls the Caldea.
The Caldea, got it.
Right. That giant tank handles all the steam for the milk and the general hot water spout. But right alongside it, the manual explicitly lists the boiler cafe.
The coffee boiler.
Exactly, labeled as 19. And crucially, it notes that this dedicated coffee boiler is multiplied. There are 2, 3, or even 4 of them, depending on the size of the machine.
Okay, let me make sure I'm visualizing this correctly. An espresso machine has these stations sticking out of the front where the coffee actually dispenses.
Right, the group heads.
Yeah, the group heads. That physical metal fixture where the hot water meets the handle holding the ground coffee. So the manual is saying that every single one of those group heads has its own dedicated, completely independent boiler sitting right behind it.
That is exactly right.
That seems like a massive manufacturing expense. Why go through that much trouble?
To understand why a company would build multiple internal boilers, we have to talk about something called thermal lag.
Thermal lag. Okay, what happens during thermal lag?
So in a traditional single boiler setup, you have one large tank of hot water. When you pull a shot of espresso out of the group head, hot water leaves that tank.
Makes sense.
To keep the tank full, cold water from the city's plumbing line rushes in to replace it. Now, if you are pulling one coffee every 10 minutes, the heating element has plenty of time to warm that new cold water back up.
Right, the heater can catch up.
But in our scenario, the 200 ticket rush, you are pulling shots back to back endlessly.
So cold water is just constantly dumping into the boiler.
Constantly. And eventually, the heating element simply cannot keep up.
Oh, I see.
The overall temperature of the boiler begins to drop. That is thermal lag. Your very first shot at 8:15 might pull at a perfect 202 degrees.
But by 8:45.
Exactly. When you're 70 tickets deep, that constant influx of cold water might have dropped the brewing temperature down to 192 degrees.
Wait, really? A whole 10 degrees. What does that actually do to the taste of the coffee in the cup?
It drastically alters the chemistry of the extraction.
Really?
Yeah, hotter water extracts the sweet, complex sugars and heavy body from the coffee.
Yeah.
Cooler water struggles to dissolve those sugars, so it only extracts the lighter, highly acidic compounds.
Oh, wow. So if you've ever been to a busy coffee shop and wondered why your latte tasted rich and chocolatey on Monday, but then tasted unpleasantly sour and thin on Tuesday.
You probably fell victim to thermal lag. You got a shot pulled from a tired, cold boiler.
That is wild. So by isolating the main steam boiler from these multiple tiny independent coffee boilers aired at the group heads, the GTI just guarantees that the temperature never dips.
It guarantees incredible stability. The 200th shot gets the exact same heat as the first shot.
That's huge for consistency.
It is. But the engineering goes one step further. Because those coffee boilers are entirely independent from one another, they don't have to be set to the same temperature.
Oh, interesting. So you could tweak them individually through that touch screen we talked about earlier.
Exactly. You can set group head number 1 to 202 degrees and group head number 3 to 195 degrees.
So you can run different profiles at the same time.
Yes. It completely changes how a cafe designs its menu.
I love this. It's like a baker working in a high-end commercial kitchen. You wouldn't want one giant oven that you constantly have to crank up to 450 degrees for crusty bread and then leave the door open to cool it down to 325 for delicate pastries.
No, you'd burn half the food and stall the kitchen waiting for the temperature to shift.
Right. You want multiple ovens running at exact, distinct temperatures.
That is the exact operational philosophy here. Think about our morning rush again. A cafe could load a dark, aggressive house blend into the grinders for group heads 1 and 2, running at a hot 202 degrees.
Okay, so those are your workhorses.
Exactly. That is how you rapidly crush the massive queue of people ordering standard mochas and lattes.
But then on group head 3,
Right. On group head 3, you dial the dedicated boiler down to 195 degrees.
because that cooler temperature is better for something else.
Yeah, it's perfect for extracting a super delicate, bright, light roast, single origin espresso for the hardcore coffee enthusiasts.
And the barista is doing all of this on the exact same machine simultaneously without ever making the line wait for the equipment to adjust.
You never wait on the machine. The thermal bandwidth is just always there.
Okay, so the touchscreen interface is lightning fast. The independent boilers are pumping out perfectly extracted, temperature-stable espresso. We are surviving the rush.
We're doing great.
But now we hit the absolute classic cafe bottleneck.
Oh yeah, the wall that every barista slams into.
Right. You have a shot of espresso, but the customer ordered a latte. You have to steam the milk.
The steaming bottleneck is the bane of high-volume hospitality.
Because steaming milk manually just takes so much time, right?
It takes time, and worse, it requires absolute physical focus. The barista has to hold the steel pitcher at a very specific angle to create a whirlpool.
Right. You always see them tilting the pitcher.
Yeah. They have to listen to the hiss of the steam wand to know exactly how much air they are injecting, and they have to feel the outside of the pitcher with their bare hand
Right.
to gauge the temperature.
Wow, so they are completely tied up.
For 30 to 40 seconds per drink, that barista is completely paralyzed. They literally cannot do anything else.
Which brings us to the most aggressive feature in the manual, the Auto Steam Milk 4 system.
Yes, we are looking at weaponizing throughput here.
I love that phrase. Weaponizing throughput.
Right.
So the diagram shows the physical auto steam pipe, which is 9A, and right above it, the auto steam selector at 13.
Right.
And it mentions you can configure this on both the left and right sides of the machine as auto steam L and auto steam R.
The key here is the selector function. This isn't just an automated steam wand that you flip on and off.
Okay, so it's more advanced than that.
Oh, definitely. The manual details 4 distinct programmable settings on that selector. You are essentially programming distinct mathematical milk recipes.
Wait, recipes for milk?
Yeah. Setting 1 might be programmed to heat the milk with barely any injected air, creating a flat, silky texture for a flat white.
Okay.
But setting 4 could be programmed to inject a massive amount of air for a dense, pillowy, traditional cappuccino.
So how does the machine actually know when to stop? Like, how does it replicate what a human hand does?
Inside that auto steam pipe, there is an incredibly sensitive temperature probe, constantly communicating with the main boiler, alongside an internal air pump.
Oh, wow.
The barista simply places the wand into a cold pitcher of milk, taps the selector for, let's say, recipe number 3, and completely lets go.
Hands-free.
Totally hands-free. The machine injects the precise volume of air required for that specific recipe, rides the vortex to fold the foam in, and the microsecond the internal probe hits the target temperature.
Say 145 degrees.
Right. It instantly shuts off the steam valve.
That is a staggering efficiency upgrade. Because while the machine is perfectly texturing the milk for that cappuccino, the barista's hands are totally free.
You are parallel processing your drink building.
Right. The barista can be pulling the next espresso shot, dumping old coffee grounds, prepping a pastry bag, or literally cashing out the next customer in line.
You are essentially giving your busiest barista a second pair of hands during the most stressful part of the day.
That is wild.
In a 200-ticket hour, eliminating 30 seconds of physical paralysis on every single milk-based drink is the literal difference between a customer waiting 5 minutes and a customer waiting 15 minutes.
Okay, I have to step in here and play devil's advocate again.
Okay, let's hear it.
Because I know there are specialty coffee purists listening right now who are shaking their heads at us.
Oh, absolutely.
They would argue that automated milk steaming is just a crutch for bad baristas. They would say it takes the artisanal craft out of the beverage. Like, if the machine does the work, where is the skill?
That is a very common debate in the specialty coffee world. And, if you are running a slow, quiet neighborhood cafe that does 50 drinks all day, maybe you prefer the manual craft.
Sure, you have the time for it.
But in our scenario, the tech cafe getting slammed at 8:30 in the morning, we have to completely reframe what a crutch actually is.
Okay, reframe it how?
In a high-volume environment, the auto steam isn't a crutch. It is a consistency guarantee.
The consistency guarantee. Tell me more about that.
Human beings are wonderful, adaptable creatures, but we get tired, we get distracted.
That's for sure.
When a barista is 50 cups deep into a stressful rush, the ambient noise is deafening, and a customer suddenly interrupts them to ask for the bathroom code. Human error spikes.
Right, because their attention is split in 5 different directions.
Exactly. The barista might leave the steam wand in the pitcher 1 second too long, burning the milk. Or they might flinch and not inject enough air, ruining the texture.
But the auto steam probe doesn't get distracted.
The probe doesn't get tired. It doesn't care about the bathroom code. It ensures that cup number 50 and cup number 150 taste exactly as perfectly textured and exactly as sweet as cup number 1.
Wow.
That level of bulletproof consistency is the hallmark of true professional hospitality.
That makes so much sense. You are automating the most volatile variable to protect the quality of the product.
Precisely.
Okay, so fast forward a bit. We have survived the absolute peak of the rush. It is now 10 a.m. The line is finally starting to die down from 50 people to maybe 5 people.
We made it through the worst of it.
We did. We have pushed out hundreds of coffees using the touchscreen, the independent boilers, and the auto steam. But now we have a very insidious new problem.
Ah, yes. The dirty machine.
Exactly. The internal valves of those group heads are coated in coffee residue. But the cafe is still open. People are still trickling in on their coffee breaks. How do you maintain the pristine quality of the coffee without entirely stopping service to clean?
This specific transition period is where most cafes quietly fail their customers.
Really? How so?
They push through the morning rush, the machine gets dirty, and because they don't want to stop serving, they just keep pulling shots through dirty equipment.
Oh, gross.
Yeah, they serve slightly bitter, degraded coffee until they finally close the doors in the afternoon.
But the President GTI manual outlines a digital solution for this, which brings us to our final operational angle: preventative maintenance without the downtime.
Let's look at the wash menu detailed in the manual's interface section. It outlines a few different rinse cycles, water, C, and coffee.
Right.
But the options that are operationally critical are the specific wash configurations. The software gives the operator the choice to run alternate, simult, which stands for simultaneous, or singular cleaning cycles.
For the listener who hasn't worked behind a bar, can you explain what physically happens when you clean an espresso machine? Because it's not just wiping it down with a damp rag, right?
No, not at all. It's quite an intensive plumbing process called backflushing.
Backflush.
Yeah. Normally, to clean the internal valves of a group head, you have to insert a blind filter into the handle. A blind filter is a solid metal basket with no holes in it.
Okay.
You drop strong chemical detergent into that solid basket, lock it into the machine, and turn the water pressure on.
But the water can't get out.
Exactly. Because the water has nowhere to exit, the pressure forces the soapy, boiling water backwards up into the machine's internal exhaust valves, scrubbing them clean.
And on older analog machines, the electronics usually force you to run this backflush cycle on all the group heads at the exact same time.
Right. It locks the entire machine out. You can't pull any coffee.
Which means the barista has to look at the 5 people still waiting in line and say, sorry, you have to wait 10 minutes. We are running a cleaning cycle.
Which completely shatters the hospitality experience. No one wants to hear that.
Exactly.
But this is where the GT singular wash configuration becomes an operational secret weapon.
Singular meaning just one.
Exactly. By selecting singular on the touchscreen, the barista can insert that blind filter and run a fully automated computerized cleaning cycle on just one dirty group head.
Wow.
While the internal computer allows them to actively pull fresh shots of espresso on the remaining group heads right next to it.
Okay, I have to use an analogy here because I love this visual.
Go for it.
It is literally like a high-stakes NASCAR pit stop. You are essentially changing the front left tire on a race car while it is still driving 200 miles an hour down the track.
That is a great way to visualize it.
You are deep cleaning the internal plumbing of the equipment, but the race doesn't start. The cafe stays open, the revenue keeps flowing.
It is dynamic, on-the-fly preventative maintenance.
Yeah.
And we need to understand why cleaning those internal valves is so critical to the actual taste of your morning coffee.
Right, what is actually building up inside the machine?
So coffee beans are packed with natural oils. They are highly volatile. When you extract espresso under 9 bars of intense pressure and 200 degrees of heat, those dark oils coat the inside of the metal group head and the internal shower screens.
Okay, so it gets greasy.
Very.
Hmm.
And if you leave those organic oils sitting there, baking on hot metal for hours after the morning rush ends, they oxidize, they turn rancid.
Oh, wow. So you are basically pulling fresh water through rancid grease.
Exactly. And every single subsequent shot of espresso you serve to a customer through that dirty group head will pick up that baked, ashy, terribly bitter flavor.
Which explains so much.
Yeah, that is exactly why a coffee shop can taste amazing at 7 a.m., but harsh and undrinkable by 11 a.m.
But by utilizing the GTI's singular digital wash cycle dynamically as the rush begins to fade, the barista ensures those hot oils never have the chance to bake.
That's the beauty of it.
You are systematically resetting the machine to perfectly clean group head by group head without ever causing a single moment of dead downtime for the customer standing at the register.
It completely removes the friction from the barista's day. They don't have to stress about finding a magical 10-minute window where no customers walk in to shut the machine down.
Right.
They just tap a button, let the machine clean itself, and keep smiling at the guests.
Okay, let's step back and pull all of this together. Taking off our hospitality consultant hats for a second, what we've really decoded from this engineering manual today is that the Faema President GTI is not just a coffee maker.
Far from it.
When you layer the rapid touchscreen interface, the thermal stability of the independent boilers, the massive throughput of the Auto Steam Milk 4, and these dynamic singular wash cycles, it basically operates as a complete workflow optimization engine.
Every single schematic and feature we discussed from this manual is fundamentally about removing a physical or mental hurdle for the human operator.
Yeah.
It is engineering designed to solve human bottlenecks.
And that is the ultimate takeaway for you listening right now. Whether you are actually gearing up to run a high-volume cafe, or if you are managing a team of software developers, or even just trying to organize your own daily routine at home, the core lesson translates perfectly across any industry.
It really does.
The best tools, the most effective systems, are the ones that absorb the operational friction so that you can focus entirely on the human experience. You automate the routine so you have the energy to personalize the exceptional.
I think that is the perfect synthesis. And, to leave you with something to chew on long after this deep dive ends, think back to our debate about the auto steam.
Oh, the crutch debate.
Right. We discussed how purists might resist automated milk because they feel it strips away their artisanal craft, even when the data proves it guarantees a vastly superior, more consistent experience for the customer.
Totally.
So ask yourself this. If automation in something as tactile and traditional as a coffee machine actually frees the operator to be more human, more present, and more hospitable, where else in your own life or career are you stubbornly clinging to a manual process out of pure stubborn pride when automating it might actually free you up to do much more meaningful work?
Wow, that is a phenomenal thought to end on. Thank you so much for joining us on this deep dive into the engineering of hospitality. Keep exploring, keep optimizing, and as always, keep questioning the world around you.